Yeah, so hello everyone. We are going to start our today's CTF workshop day 4 organized by Cyber Security Student Society. Our today's topic is cryptography, learning objective, introduction to cryptography, and some basic concepts of cryptography. So myself Adil Ahmed, today's host, and our guest speaker Misa Zaidi. She's a web security specialist, OWASP. And so without wasting time, I just want to mm, yeah, just wait on it. Yeah, so sorry for wasting some time. So Zaidi, you can start now today's workshop, CTF workshop day 4.
Hello everyone, and welcome to the CTF workshop. My name is Zaidi Mesa. I will be your trainer for the cryptography course. I will present you the course. So we will begin. We will begin by cryptography. Cryptography is the reason we can use banking apps, transmit sensitive information over the web, and in general protect our privacy. So, the word cryptography technically means the art of writing codes. Cryptography is the science of encrypting and decrypting data to prevent unauthorized access. So, encryption is the process of making the plain text unreadable to any third party, which generates the ciphertext. Decryption is the process of reversing the encrypted text to its original readable format. This is the plain text study. We encrypt it to the ciphertext, then we decrypt it into plain text, and it will be studied again. There are two types of encryption in cryptography: symmetric encryption and asymmetric encryption. First of all, what is symmetric encryption? If anyone have any question, feel free to ask because I can't see the messages. You can speak if anyone has a question. Symmetric encryption algorithm relies on a single key for encryption and decryption of information. Both the sender and the receiver of the message need to have a pre-shared secret key that they will use to convert the plain text into ciphertext and vice versa. As shown in the figure, the key which is being used for encrypting, I'm ready, the original message, is decrypting the ciphertext. This is the ciphertext. The key must be kept private and be known only to the sender and the receiver. So, Jane, this is the receiver. If Paul wants to send a simple message to Jane, they need to have a single encryption key that both of them must keep secret to prevent snooping by malicious actors. If the message "I'm ready" is converted to ciphertext using a specific substitution cipher by Paul, Jane must be aware of the substitution shift to decrypt the ciphertext once it reaches her. To sum it up, the enter process will be as shown below. Step 1. Paul and Jane decide on a common key to be used. Step 2. Paul sends the secret encryption key to Jane. Step 3. Paul uses the private key to encrypt the original message. Step 4. Paul sends the encrypted message to Jane. Step 5. Jane uses the secret key to decrypt the message that was already present with her. Following the above process, Paul and Jane communicate privately without the fear of anyone lurking on the route. Since only both of them have the secret key needed to encrypt and decrypt the message, no third party who can intercept the encrypted message can break into it. Now that you have a foundation, it's time to walk you through its applications. So, where is symmetric key cryptography used? Symmetric encryption is essential for many day-to-day activities on the internet, running from safe online browsing to banking applications. Some of these applications are as follows: banking applications to authenticate ID and transactions. Server data center information can be encrypted at rest. HTTPS encryption with secure all-around browsing. Payment application. Many online banking and payment applications require the verification of personally identifiable information before proceeding with their transactions. It helps in predicting the correct information to prevent fraudulent activities and cybercrime. Securing data at rest. So, when a website or organization stores personal information regarding their users or the company itself, it is protected using symmetric encryption. This is done to prevent all kinds of snooping from either outside hackers or disgruntled employees inside the office looking to steal critical information. SSL TLS handshake. Symmetric encryption plays a significant role in verifying website server authenticity, exchanging the necessary encryption keys required, and generating a session using those keys to ensure maximum security instead of the rather insecure HTTP website format. So, what are the advantages of using symmetric key for cryptography? Symmetric encryption has a few advantages over its counterpart, asymmetric encryption. We will talk on it as asymmetric encryption, which uses two different keys to encrypt and decrypt data. Some of these advantages are faster than asymmetric, better performance metrics, easier to set up and implement, optimizing for bulk amounts of data. So we talk about asymmetric key. So what is the need for asymmetric key for cryptography when we have the symmetric encryption? So let's talk about this short story to explain more the need for asymmetric key. So Joe is a journalist who needs to communicate with Ryan over long distance messaging. Joe uses symmetric encryption while sending his messages to prevent them from falling into the wrong hands. However, the tricky part comes when Ryan needs to receive the decryption key for the encrypted data. You face a critical problem here when it comes to the key exchange. The encrypted messages in transit are not a risk to either sender or receiver, since unauthorized people can't read the content. But the decryption key, on the other hand, if intercepted, exposes all the information Joe has to disclose to Ryan. So this is the dilemma asymmetric encryption has fixed because of its multiple key architecture. So what is asymmetric encryption? Asymmetric encryption algorithms use two different keys for encryption and decryption. The key used for encryption is the public key, and the key used for decryption is the private key. Both the keys must belong to the receiver, as you can see in the image above. Using different keys for encryption and decryption has helped avoid the problem of key exchange, as seen in the case of symmetric encryption. This is the original text. We have two keys, public key and private key. In the encryption, we use the public key. Everyone can have the public key, and when we decrypt the encrypted data, we use the private key to access to the original text. For example, if Alice needs to send message to Bob, this is Alice, this is Bob. Alice needs to send a message to Bob. Both the keys, private and public, must belong to Bob. So the plain text is call me today. The cipher text is this. So the process for the above image is public key to encrypt the message. Step 2, the encrypted message is sent to Bob. This is the encrypted message is sent to Bob. And step 3, Bob uses his private key to decrypt the message to access to the original text call me today. To understand the asymmetric key cryptography architecture clearly, consider the process of sending and receiving letters via physical mailbox. So, as shown below, anyone who has the postal address, the public key, in our case, can send the message for public. Anyone can have it. However, only the receiver can read all his or her messages thanks to the mailbox key that no other person can have. In this story, the mailbox key is the private key, the owner with the private key. Can see here. This eliminates the need to exchange any secret key between the sender and the receiver, thereby reducing the window of exploitation. So, when we don't need to exchange the secret key between the sender or the receiver, we reduce the window of exploitation. Now we understand the base terminology and process behind the asymmetric key cryptography. So, where is asymmetric key cryptography used?
Okay,
Asymmetric
so
key
hello.
Hello, yes, speak.
Yeah, can you hear me? So I have a question regarding symmetric encryption. Suppose we want to communicate with each other and we want it to be secure. So
Yes.
how exactly we are going to exchange our keys, because it can be a problematic if we are exchanging a key that will be used for the encryption and decryption. So how exactly we are going to communicate that key so that it can be transferred securely over the channel without being hacked or exploited.
Okay. In symmetric encryption, we have one key is a private key. The receiver knows it. No one can access to this private key. But in the encrypted encryption, the receiver and the sender cannot decide the key, or they must message to send the private key. So in asymmetric we need a public key and a private key, but in symmetric encryption we don't need we need one key that the sender and the receiver decide to use it. It's like this, you can see it here. Paul, Paul and Jane decide on a common key to be used in encryption. In symmetric encryption, the receiver and the sender decide on a common key to be used. But in asymmetry, we have two keys, public and private key, different keys, key for encryption and key for decryption. Are this clear or not?
I think, I
What?
guess maybe if my internet or the voice is lagging a lot at your side,
Yes.
can anyone make sure that, I mean, the internet of hers or there's a problem at my side?
Speak, Yusuf. Okay.
Okay, maybe it's my side. Okay, you can carry on because maybe that would be problematic for me to question you again as I didn't get it. Anyways, you can keep on with the session. Thank you.
Okay, if you need anything, you can message me on WhatsApp or on LinkedIn. So I will put my LinkedIn link if anyone. So,
Of course. Thank you so much for that.
okay, thank you. So, we talk about where is asymmetric key cryptography used. Asymmetric key cryptography has found use in many authentication domains thanks to its thorough identity verification process. Some applications are as follows: digital signature to maintain authenticity of documents, encrypted browsing, sessions for better protection against hackers, managing cryptocurrency transactions securely, sharing keys for symmetric key cryptography. So, digital signature, verification of document origin and signature authenticity is possible today thanks to asymmetric key cryptography, TLS SSL handshake. Asymmetric key cryptography plays a significant role in verifying website server authenticity, exchanging the necessary encryption keys required, and generating a session using those keys to ensure maximum security instead of the rather unsure HTTP website format. Cryptocurrency. Asymmetric key cryptography uses blockchain technology to authorize cryptocurrency transactions and maintain the integrity of its decentralized architecture. Key sharing. This cryptography category can also be used to exchange secret keys for symmetric encryption, since keeping such keys private is of utmost importance in its system. So let's dive now into XOR basics. An XOR or exclusive OR is a bitewise operation indicates by or this and shown by the following truth table. So 0 or 0. Exclusive XOR, we have 0, 0 or 1, 1, 1 or XOR 1, 1 XOR 1, 0. So encryption using XOR. Take data represented in binary and perform an operation against another set of bits where you get a 1 only if exactly one of the bits is 1. So 1 XOR 0. 1 XOR 0. 1. Here we find 1. 1 XOR 1. 0. Because 1 XOR 1 is 0. 1 XOR 0. 1. 0 XOR 1. 1. And finally, we get this. So what does this have to do with CTF? encryption by XOR. XOR is a cheap way to encrypt data with a password. Any data can be encrypted using XOR, as shown in this Python example. So we have this variable data captured the flag. His content is captured the flag. Our key is A. So we encrypted it. Join char ord x XOR the ord of the key. X is for X in data. So each alphabets here we XOR with the key. Uh, this ord to convert it to binary. So C and XOR A XOR A, P XOR A. This is the for book. So encrypted. This is the encrypted message of capture the flag. And when we want to decrypt it in Python, so decrypted is the same here, but for X in encrypted, not in data. In encrypted, X is the alphabets in data here, but in decrypt, X has take each character here and XOR with the key. So when we show the decrypted message is already capture the flag. So exploiting XOR encryption. We have to single byte XOR encryption. Single byte XOR encryption is trivial to brute force as there are only 200, 255 key combinations to try. Multi-byte XOR encryption. Multi-byte XOR gets exponentially harder the longer the key. But if the encrypted text is long enough, character frequency analysis is the available method to find the key. Character frequency analysis means that we split the cipher text into groups based on the number of the characters in the key. These groups then are brute forced using the idea that some letters appear more frequently in the English alphabets than others. So, right now we will talk about Caesar. The Caesar sphere or Caesar shift is a sphere that which uses the alphabets in order to encode text. So Caesar encoded with shift of 8 is chimade. So this alphabet becomes this when we shift with 8. So A will be 1, 2, 3, 4, 5, 6, 7, 8. This is will become A. This is B become G. Guess? Yes. We shift with 8. So Caesar, the first alphabet, we shift at 8. See here. See 1, 2, 3, 4, 5, 6, 7, and 8. This is Q. This is Q. And A will become A. A will become here 4. Guess 5 will become M. Yes. So uh, root 13 root 13 is the same thing but a fixed shift of 13. This is a trivial cipher to brute force because they are only 25 shifts. So encryption Caesar sphere shift over the alphabets a certain number of places and substitute the original letters for the shifted letters A, B, C, D. So high word become to index. So when we search from high, this is high, will become T, U. This is. And word, when we search from the W, I, word, O, O become A, and the R become D, L become X, this is L, become X, and the D become P. This is the encryption. High word became this. So let's dive into Visioner Sphere. A Visioner Sphere is an extended Caesar sphere where a message is encrypted using various Caesar shifted alphabets. The following table can be used to encode a message or decode also. So the encryption, for example, encrypting the text super secret with the code. This is the key code. Would follow this process. Code gets padded to the length of super secret. So becomes code, the same length of super secret of our original text. For each letter in super secret, we use the table to get the alphabet to use in this instance row C and column S. The cipher text first letter then becomes U. So S, we will go to the table in the instance row C because this code C the row and the column S. We will find you. Let's show. This is C and we search for S. Oh, this is S. So this is the first alphabet for our encrypted. So the second for our original text U, and this is O. U and O. So here the O here and the U. We search for it. We will find A. We will show. So this is right. U and A. And like this, so we get this is the ciphertext of or the encrypted text of this original text. Super secret becomes this text by this code by the key. This is code. In the decryption, we go to the row and find the key. In this case, C. Find the letter of the ciphertext in this row. In this case, U. So we go to the row C and we search for U, and we find the first alphabet is S. So the second I, this, we go to the row with O, and we search for A, and we can find U. So this is like this. This is the Visioner sphere. It's very easy to code. So let's now talk hashing functions. Hashing functions are one-way functions which theoretically provide a unique output for every input. MD5, Chai1, and another hashes which were considered secure are now found to have collisions or two different pieces of data which produce the same supposed unique output. String hashing. A string hash is a number or a string generated using an algorithm that runs on text or data. The idea is that each hash should be unique to the text or data, although sometimes it isn't. For example, the hash for dog should be different from other hashes. So we can use command line tools or online tools like echo dash n password pipeline MD5. So we can get the hash of the password. Here is the hash. So this is different hash using S1, T2, MD5, CRC32. Generally, when verifying a hash visually, you can simply look at the first and last four characters of the string. File hashing. A file hash is a number or string generated using an algorithm that is run on a text or data. The premise is that it should be unique to the text or data. If the file or text change in any way, the hash will change. What is used for? File and data preparation. How can we determine the hash of a file? You can use the MD5 sum command. MD5 sum simple file .txt. This is the hash of our file. When we change anything in our file, the hash will change. Let's talk about hash collisions. A collision is hash. This is very rare, of course. Passwords are usually stored as hashes on a computer. Since it's hard to get the passwords from hashes, so this is the password. It's easy to hash it, and it is too hard to go from the hash to the original password. So this is all the first session. We talk about symmetric and asymmetric encryption. We talk about XOR, and we talk about hashing, and we talk about Caesar Sapphire, Route 13, and we talk about Visioner Sapphire. If you have any questions, please ask me. I'll check messages. Yes. Wait for the information. TLS 1.2 and TLS 1.3, which more secure? I don't have information exactly about TLS 1.3 and TLS 1.2. I think that.
जायदा यूसुफ बोलते.
Yusuf, we can't hear anything.
So I just heard about this encryption. So what is the difference between TLS 1.3 and 1.3?
I don't have information about TLS 1.2 and 1.3. And the next session, I will reply to this question.
Okay.
So, in the next,
Yeah,
yes, Adele,
I have question.
yes.
What are the main differences and use cases for these hashing algorithm, yeah, such as MD5, SHA-1, and SHA-2? Can you please explain?
MD5, okay.
Yeah, SHA-1 and SHA-2, as you teach us in previous slide.
MD5 and T1 is an encryption algorithms. Uh, it's you can use different hashing algorithm. I think it's the same. We can use MD5 or SJ1. I think that J2 is more secure than J1. So that's why we use different hashing algorithms. We can use this command line MD5 or MD5 uh, to hash strings or files. So uh, this hashes is used we can use anything to hash files or strings. It's the same. Yes.
Yeah, which algorithm mostly using nowadays? MD5 or SHA-1? Which one?
I guess MD5. I don't know exactly, but I guess MD5 it's more used to J2. So in the next session, we will get hands on CTFs in cryptography, and we will use these commands, and we will learn more about MD5 and J2, J1, uh, and we will dive into the hands-on and CTFs. So I will say to you, get ready for the next trip to the world of cryptography. So this session, we talk about cryptography in generally, some concepts and techniques in cryptography to explain more what means of cryptography and when and where we uh, we use cryptography. So in the next session, we will solve CTFs in cryptography CTFs, and we will talk about tools next session. to solve these cryptography CTFs. So I will share with you my LinkedIn link for anyone send a message. So this is my LinkedIn link, and this is my Gmail. If anyone has a question, he can message me. And thank you for your presence in this session, and welcome to the next session.
Yeah, thank you so much, Maisa, for such an informative session. And today's session is ends here. Thank you so much, all of you, for